Another approximation method is one we call the Simpsons rule, and it's got no relation to Bart and Lisa and Homer and all those. What Simpsons rule is about, like trapezoidal rule was forming trapezium between curves, where Simpsons rule is about creating a quadratic polynomial or a parabola between each of the points on the curve there. So that's how we do this. That's how we do the approximation. In that case, instead of a straight line, we use a quadratic polynomial or a parabola. So we have the same idea as we're going between 2 points A and B, and we're going to split them up into number of strips when we're going to have the H value again. So H is the same. H is B minus A on 2. It's on an N, sorry. So where N's the number of strips. So you can see it goes up by the same amount each time. This time though, our formula is a little bit different. And this time it's going to be H on 3. So there's the first difference. So the H value, like we had before, it's not on 2 this time, it's on 3 for trapezoidal, for the Simpsons rule. Again, we're going to have the first value plus the last value there. So we have the first and the last. But now what we're going to do is we're going to have what we call odds and evens. So if we take out our first value here, this would be our our first y value. So we have y0, and that's why I label it y0, because the first value is there. Then the next value here is what we call our first odd value. That'd be odd. This one would be even. Then this one would be odd. Obviously, we ignore the last one because that's not that the first and the last get added together. So we have the first plus the last. Then we start to say, well, 4 times the odds, 2 times the even. So every alternate one, we multiply the first one by 4, and then next one by 2, next one by 4, then by 2. So we can sum the odds and sum the evens, and 4 times the odds, 2 times the evens. Some texts you may see swap these around. Now that depends on whether they start and labeling their values as x0, y0, or they start at x1, y1. Depends on what. If they start at x1, y1, they'd swap those around. I generally take it as x0. So that's why I have 4 times the odds and 2 times the even. That's generally what most people do, but sometimes it gets swapped around depending on the text you use. So just be aware of that. So this time we want to approximate 1 to 5 of x times natural log of x. So there's no way you're going to be able to integrate that in this course. So you're going to have to use either trapezoidal or Simpsons. Using Simpsons rule with 5 function values in the table. So there's our 5 values. We're going from 1 to 5, so it's going to go up by 1. H is 5 minus 1 over 4, because that's the number of intervals we've got. So that gives us going up by 1. So that's where we get the 1 on 3. So we're going to have our first value, which is 0. Our last value is 8.047. So first plus the last. And then our odd values would be this one and this one. Because you can see, like, take out the first one, take out the last one. That's an odd value, that's an odd value, because 1, 2, 3. So that's why we sum the 1.386 and the 5.545. Add those together, multiply them by 4, and the middle value we're going to multiply by 2, because that'd be an even value. Once you're at that point, sub it into the calculator, and we want it corrected 2 decimal places to get that answer. So again, this one here, we've got H is really spelled out for us because it's 150 each time. 150 over 3, so there's a H on 3. The first value is 700, our last value is 700, so that's why we get 700 plus 700. And then our odd values are 1200 and 1200 there. And our even value would be the 1500. So we can put that in the calculator and get the 700,000 meters squared. And this might be an exact way, this might be a way they do this. Obviously, if you're going to do it in a real life situation, you probably take strips that are smaller than 150 meters, which means you'd have more values this way. But again, a lot of situations, this would be put into a computer and calculated. So you'd just be having to plug in a lot of values, and the computer would work it out for you. But they would use this type of rule to actually find an area, because you're not going to find the area exactly, but you can get a pretty good approximation. So this time Simpsons rule is 3 function values and 0 to 1, which means if we've got 3 function values, 1 minus 0 divided by 2 gives us the half. So it goes 0, a half, 1. So our value of h is a half there. Our first value is 0, our last value is 1, so that's the 0 plus the 1. Then it's just 4 times the odd. There's no even, there's only the one middle value, so that's only an odd value. So 4 times this 1 on 16 gives us that value there, 5 on 24, or 0.2082, 3 significant figures. Again, Simpsons rule going from 3 to 7. So, and the functions, you see that will in the table here we're seeing that the value of h is 1 because it goes up by 1 each time. So that's our value of h. Our first value is 11.2, our last value is 20.5. Then we're taking 4 times the 9.8 plus the 13.4. There are odd values, and our even value would be 12.7. So we're going to take 2 times that, and we throw it into the calculator. Again, I remember these rules, trapezoidal and Simpsons rule, by words rather than by symbols. It's just a little bit easier. Remember the first plus the last, 4 times the odds plus 2 times the evens. It's just a little bit easier, I've always found, that way. How you remember it is up to you, but you've got to try. You've got to remember it because you're going to have to apply these rules to approximation methods and to solve.